TME students, interim candidates. So this is another past question. When you are given this question, how do you solve it? Let's solve together. So the question says the oxidation state of chlorine in potassium chlorate is the oxidation state of chlorine in potassium chlorate is what? So solution. So in this context now, what they are asking us to look for is the oxidation number of chlorine in potassium chlorate. So we are this is potassium chlorate. So we'll write it is KClO₃. See, this is small l. So potassium chloride. We are looking for the oxidation number of this chlorine. Let me write it here. Chlorine is potassium chlorate. Oxidation number of chlorine in potassium chlorate. I hope that is clear. So now to find oxidation number, there are rules, and for a compound like KClO₃, which is potassium chlorate, you have to take note that this is a neutral compound. A neutral compound. And there's a rule I'm going to state that will help us solve this question. You know, the rule states that the oxidation numbers of the sum of the oxidation number, I'm trying to cause it from my head so you guys will understand. The sum of the oxidation number of the individual elements, or let me just say the atoms of individual element, the sum of the oxidation numbers of the atoms of individual elements that make up a neutral compound is equal to 0. So the sum of this is made up of this is potassium, this is chlorine, this is potassium, this is chlorine, and this is oxygen. The sum of the atoms, the sum of the oxidation number of the atoms of each element that make up a neutral compound is 0. It means that the sum of potassium and chlorine and the sum of the oxidation number, take note, and oxygen here is not just one atom, it's 3 atoms. So we can put it as 3. We have 3 atoms of oxygen here. So this is just one atom of potassium, one atom of oxygen, and 3 atoms. That's why I said the oxidation number, the sum of the oxidation number of the atoms of the individual elements that make up a neutral compound is what? 0. So you have to know the oxidation state of, or oxidation number of potassium. Oxidation number of potassium is an alkali metal, so it's +1, or we can just simply write it as 1 plus. We are looking for the oxidation number of chlorine, so we can just put chlorine, just leave chlorine like that, or you can make it as X. You can just leave it as X or chlorine, because that's what we are looking for. And the oxidation number of oxygen is what? O2. I said O2 minus 2, or 2 minus equals 0. So through using this, you can look for oxidation number of chlorine. So 1 plus Cl plus 3 times minus 2 is what? Minus 6, right? Equals 0. So we have 1 plus Cl plus times minus is minus 6 equals 0. Sorry for using red pen. So 1 plus, okay, let's just collect like terms. Cl equals 0. This comes here. Remember, this is +1. I did not just put it because plus 1 is also +1. +1 is also 1. So you don't have to put the plus there, but just that this is also +1. When this comes here, it turns to -1, right? Or let me first bring this one here. When this comes here, it turns to +6. -6 turns to +6. This one turns to -1. So we have Cl equals 0 plus 5. 6 minus 1 is 5. Or 0 plus 6, 6. 6 minus 1 is 5. So Cl equals +5. 5 or +5. 5 is also for 1 is +1. 2 is +2. 3 is plus 3, 5 is 3. That's why it has the invisible plus here. You don't need to put it, but here you know you have to put it because it's oxidation number. The this thing is important. What's it called? The sign is important. So plus 5. So that's plus 5. So just take note of that rule. So take note of the rule. When you are giving something like this, you write out what the compound, and you take note of the rule that the sum of the oxidation numbers of the individual of the atoms of individual elements, I'm saying atoms of individual elements in case you have maybe something like O2, O3, you know that this is more than one atom, so it's going to be 2 multiplied by the oxidation state, or 3, or maybe you have um, we have O4 for example, so you know it's 4 minus 2. I hope that is clear. So that's how you look for oxidation state. Simple. Follow, ensure you subscribe for more videos.